We will now extend the previous hierarchical application, hierarchical data viewer with graphical views. We'll basically generate code like this one, which is translated by GraphViz into graphical views like this ones, and basically from a query that you can specify and run here, yeah, you can select different columns and show the graph according to the functionality of these columns. You see the parent-child relationship, hierarchical relationship is illustrated by these two columns, manager ID, employee ID. You can select a display column here, display name. You can eventually, yeah, select a group column, and you see your entities will appear each in a different department. You can select a measure, a numeric column, and definitely what you'll get will be a bubble chart.
Copy and paste in a new Streamlit application the content of the streamlit.py file that is attached as a resource to the current lecture. I already did it here, so what I did as well, so the Streamlit application, I created it as usual in the apps public schema, yeah, with a default compute warehouse that I have here extra small, okay. I replaced, as you can see here, the title of the application with a displayed title that I have here. And let's have a look at the code, okay, because this will use, basically, you can see here, the same views that we created before. There will be differences. As you can see here, I rather pass an SQL query to execute, not just the name of the table of or the view. But for the rest, let's have a look. I display also the pairs that I have here. Okay, data. Yeah, you can see manager, employee. Okay, because I use by default the employee managers here. What I will do, however, what this code will do, you see here, make graph. This will make a graph from our data, okay? And this will create a dgraph in this case. It's not so complex. It's not so complex. Have a look at the code first, okay? For every name, okay, I bring the name here, and yeah, I can use also a label. Yeah, I try to complicate this, but usually you can just create these pairs. You see, for every link that you'll have in your graph, you have to add such an entry, like here. Yeah, Nina Gonchar, okay? Let's say, look here, Stephen King. Stephen King, yeah, will have as a subordinate Lex Dihan, Nina Gonchar, or Dan Raffaelli, and so on, okay? You can separately declare nodes if you want a different label. For instance, here I can replace what I want to show for De Raffaelli browser. But yeah, it's not the case here. It's not the case. Look, this code is called dot notation, okay, DOT, and this is used to render GraphViz graphs. If I switch to graph, this is what you get. Yeah, this is what you get, guys, for every pair that I declared in the code here. You can see everything was translated, and the layout. This is very important. The layout was rendered automatically, and this is great. This is great because you don't have to worry about the layout if you pass different data. So okay. So let's have a quick look at what the code does. Yeah, it's not very complex. It's not very complex. It's the same you see here from the first two columns of the executed query result. Okay, we pick up the parent and the child. Okay, then we pass this structure here with parent child, yeah, to the make graphs. Yeah, make graphs, and in rows I have all my data. Okay. I will not bother you too much about this one. If you want more details, you can study closely, not only this code, but I will leave you links to my more elaborate articles on the web describing all this and having other versions there. In the meantime, let's have a look at something else, and let's jump up directly to, let's say, look, I want to run another query, select everything from animals. I will simply copy and paste this here, okay, and I get a different architecture. I get a different layout here, okay. So basically, you can share this small application with people, with other users from your organization, okay? And they can render, graphical data you may have in different tables of yours, the same way we have it here. And what's also important, have a look at this one, yeah? I can copy all this, and look, we have online several, not just this one, several graph visual editors. But I'll simply replace the data, yeah, that I got here, and instantly I will get a graph representation here. So what's great is because look, you can edit this one, Animalia 2, and in this case you see the top node here changed. Back to our Snowflake account, look what I did here. I copied and pasted into another new Streamlit application, the content of Streamlit 2.py file, which is attached as a resource to the current lecture. Okay, and I executed this right away. You can see that we already have a few differences here, but let's have a look at the differences. So the queries that you can execute, you can change, and you can execute with run this time. Okay, there's not a big difference, but look, if I expand, yeah, let me just close the code here and expand the sidebar. Okay, Streamlit applications may come up with such a left sidebar, which would be collapsed, could be expanded, but you may add filters here. And in this case, look, I select everything from employees view. An employee's view, okay, has several more columns here, not just, it's more complicated because look, I don't have the manager name. I have the manager ID. So in this case, I have another algorithm in my Streamlit app that does this. By default, I will pick up, yeah, the first column as a parent column, just like before. Yeah, the second column as a child column. But look, you can specify the display column. In this case, employee name. Okay, automatically I just came up to simplify everything as a result of this query or these columns in this order. Yeah, because I will pick up this specific order to automatically select this kind of columns. And look, you can select also a department, a group column, and a value column. Yeah, what does it mean? What does it mean? Let's switch to this one. And wow, that's more complex now. That's more complex. So when you selected a value column, this will show a bubble chart. So in this case, our measure here is a salary, and the bubble is bigger for those people with a bigger salary. In this case, as expected, you can see Stephen King has the largest bubble, yeah, has the largest salary in the company. So yeah, this is actually a bubble chart. Okay. For the group column, you can group, you see, within a rectangle, all the people from a department. Okay. So for the display name, as I said already, you see, you can pass IDs, yeah, for the child and parent, but automatically all the IDs will be translated into employee names. Okay. So a lot of functionality that is covered, yeah, but by this iteration of our Streamlit app. And yes, let's just remove the salary from here, and you can see everything is rendered instantly. Yeah, I no longer have bubble chart, but I still have everything grouped, which is good. And you can always switch to code, yeah, because I will provide the code, the graph, yeah, in that notation. And you see, it's interesting for the groups. Yeah, for the groups, I will use subgraphs and so on. But once again, this is Gravis specific notation. You don't have to learn about Gravis. You see here, you can see right now the purpose of the labels, because the labels are displayed instead of IDs. And I try to put everything into double quotes because, yeah, you may have special characters and so on. Yeah, not the case here, but let's try to make it very generic. So once again, I think this could be a very, very useful application. Okay, especially because the level of customization is even higher. And look, you can specify a different group column here. Let's say by job. Okay, so everything will be encapsulated by the job title: president, VP, manager, and so on. So a lot of functionality with very small changes. Okay, and another final iteration, as you can see here, I created yet another Streamlit application from the Streamlit 3.py file, which is attached as a resource to the current lecture. And yeah, it's created the same way, nothing new here, but you see the difference. Get shape properties, okay? This is different here, and I have, if you scroll at the end here, yeah, if you scroll at the end, you'll see that I will use a checkbox in the sidebar. You see this one, expand all. So basically, I will keep it just like before, yeah, with manager ID, employee name, department salary. But if you click expand all, okay, let's do it. Let's do this and let's hide. Let me hide this one. Okay, and let's see what we get in the graph. And yeah, I expect there's a lot of information here. Yeah, let's just remove, let's say the bubble here. You may not need the bubble. Okay, I just remove this one. Everything is calculated once again, and this will render the properties, yeah, the rest of the columns basically from, as you can see here, from the returned by our query here, yeah, in each entity here. Okay, let's remove also the department, because basically sometimes you just want to get something nice the same way we got it before with employee names only, but you want to see more detail. And yeah, you can try to fix it. You see, for me here, the rest is not rendered properly necessarily, and so on. Try to find why. Try to expand this one. Yeah, if I click here, if I uncheck expand all, as expected, I will get a very, very simple hierarchy, which just employee names. I love this application. Look, and I try to demo it as much as I can to different potential customers that I have. I demoed it in the past, so some people, and yeah, people will love it because yes, once again, you can get with minimal effort, amazing results. And as you can see here, yeah, it's important to have this different functionality of bubble chart, yeah, to show a measure. With this one, grouping is important, and you saw that we can group by department, as it's in the picture here, but or you can group by job or job title and so on. And yeah, definitely you can expand all and encapsulate other information properties in each entity here. So what we've seen with these iterations here, that definitely you can represent parent-child relationships as connected graph-based graphs. Okay, and you can switch the direction. Yeah, we didn't show this here, but you can show from parent to child or to child from parent, and yeah, render from left to right to left is basically trivial because it depends, on the directions that you show when you represent a link parent, and you show an arrow to child. Okay, you can show child, arrow, and parent. Okay, it's trivial, it's basic. Okay, you can use, yeah, as you've seen here, and this was important, as I said, an additional level of grouping, yeah, with subgraphs in GraphViz. Okay, we use it also as a bubble chart with a measure column. Yeah, you usually have to come up with a numeric column there, okay, to make sense. And yes, in the last iteration, we showed additional property values in the box. Uh, yes, in this case, you could try to adapt for multiple top parent nodes or to add a dummy node and so on. So once again, that's an edge case. I'm not sure the application, the prototype that I came up with, covers all these possible angles. So I'll just give you some hints. And once again, this was important because this was generic also. This works for any such pairs, yeah, from a table view, and not just pairs. We added more columns, yeah, as you've seen before. And it's important already to mention that this will not scale very well for a very large number of entries. Yeah, As you've seen before, if we try to display too much information, to display also properties with a bubble chart, with and so on, this becomes harder to read, harder to represent. So you may imagine, you can imagine, that's a case for any chart, basically, that once you add a lot of information there, the representation, the graphical representation becomes difficult.